We'll continue from yesterday's class, property 2. Today we are going to discuss about how cos inverse of cos x, the graph of this function looks like in different intervals. Okay, so let us discuss. So domain of this function, x can have all the real numbers. So domain is all real numbers. And range of this function, we know that in range of cos inverse function is from 0 to pi. So for our convenience, let us consider this function to be fx, that to be equal to y. So we'll try to draw the graph of y equal to fx. Okay, that will be our aim. Now, for drawing the graph, let me simplify the function to cos y equal to cos x. And we know how to solve cos y equal to cos x, right? Y will be equal to 2n pi plus minus of x, where n is any integer. Where n is any integer. Okay. Now put n equal to 0. We'll get y equal to x or y equal to minus x. Now we know that y, that is this value, and this is nothing but the range of f, is lying between 0 to pi. So this implies for y equal to x, x also will lie between 0 to pi. So when x is lying between 0 to pi, the graph will be y equal to x. Okay, and when for this y is lying between 0 to pi, so minus y will lie between minus pi to 0, and minus y will be equal to x, so x will be lying between minus pi to 0. So from here we are getting two results actually. Y will be equal to x when x is lying between 0 to pi, and minus x when x is lying between minus pi to 0. Then let us put n equal to 1 here. So what will get y equal to 2 pi plus minus of x. Again, it can be converted into two results. Y equal to 2 pi plus x and y equal to 2 pi minus x. So we'll find out the interval in where x lies now because we know at which interval y lies. So y is lying between 0 to pi. X and y are connected like this, so I need pi minus 2 pi. So minus 2 pi, y minus 2 pi, minus pi, and this one is nothing but x. So when x is lying between minus 2 pi to minus pi, y will be taking the value of 2 pi plus x, and from here we know y is lying between 0 to pi. So x will be equal to 2 pi minus y, so I need minus y minus pi to 0. So I need 2 pi minus y, so 2 pi has to be added. Pi, 2 pi minus y, 2 pi. So from here we are getting, if I combine these two, I'll get y equal to 2 pi plus x if x is lying between minus 2 pi to minus pi, and 2 pi minus x when x is lying between pi to 2 pi. This one is nothing but x. Okay, So now we can draw the graph. We are in a position to draw the graph by noticing that cos x is a function periodic with fundamental period 2 pi. So cos inverse cos x also will be a function with fundamental period 2 pi. Okay, so let us draw the graph considering these two facts. This one over here and this one. We have got different values of x, and accordingly we have got different values of y, that is fx. Again, so we'll draw these 4 intervals, then we'll repeat the graph because we know that it is a periodic function. So let us draw it. Domain of the function is all the real numbers, and range is 0 to pi, means the graph will never go below x-axis because the range is 0 to pi only. Now for this interval 0 to pi, 0 to pi, the fx will take the values of y equal to x. So y equal to x till pi. Y equal to x in 0 to pi. Then this one is saying from minus pi to 0 it is minus x. So minus pi to 0, minus pi, minus 2 pi. Minus pi to 0 it is minus x. Y equal to minus x. Okay, now this one is saying from minus 2 pi to minus pi, from minus 2 pi to minus pi, it is 2 pi plus x, 2 pi plus x, to look like this, y equal to 2 pi plus x. In fact, we need only this part of this portion of the graph. This is going to repeat over and over again in an interval of 2 pi. It is going to repeat. So this part of the graph will look like definitely this, and it will keep on going. The graph will keep on going like this for the entirely infinitely many real numbers. Okay, so here I'll get y equal to, from pi to 2 pi, y equal to 2 pi minus x. So this is how we draw the graph of fx equal to cos inverse of cos x. Okay, exactly same way we can draw tan inverse of tan x. I'll again advise you to learn the graph of tan inverse of tan x yourself, and same goes for cosec inverse of cosec x and sec inverse of sec x, of course cot inverse of cot x. Okay, so let us take a few questions before we proceed further. In the last class I have forgotten to mention you about the graph of sine inverse of x, cos inverse of x, tan inverse of x, the graph of this basic function. I have forgotten to mention. So let me discuss that sine inverse, cos inverse, tan inverse at least. Okay. Now you see, the last class we have discussed that sine inverse x is an inverse function of sine x, and we know the trick of drawing the graph of inverse function if we know the basic function fx. Okay, what we do, we draw the basic function fx, and we take the image of fx, graph of fx, above the origin, that is the line y equal to x, and that image will give us the inverse function graph. Okay, so we are going to do exactly that. Okay, we know sin x ka graph. So in order to draw the graph of sine inverse of x, what we'll do, we'll take the image of the function of the graph of the function sin x about the line y equal to x. It is about the origin. Okay. Now we need to draw fx equal to sin inverse of x. Its domain is here. This function ka domain is minus pi by 2 to pi by 2. Is it domain? No, domain is minus 1 to 1. This is the range, and range of this function, this is domain of f, and range of f is minus pi by 2 to pi by 2. So let us draw sin inverse x graph. So first of all, we'll draw sin x. Sin x will be something like this. So we have to take the image of this on the line y equal to x. So let me draw y equal to x. Take the image of this graph on this line. I hope it is visible. Y equal to x. Okay, and let me draw the graph with different color. This part, if I'll take the image, it will look like this. And this part, if I'll take the image, it will look like this. Now, the domain of sin inverse x, this one, is, so this point, domain means the values of x. This one will be from minus 1 to 1. And the range is minus pi by 2 to pi by 2. So this point here and this point here will be minus pi by 2 and pi by 2. Okay, so this is the graph of sin inverse of x. This was sin x. That one will be the sin inverse of x. This being y axis, x axis, and origin here. Okay, similarly we can draw the graph of cos inverse of x. Okay, let us go for it. So we'll draw for cos inverse of x now. We'll draw the graph of cos x first. Something like this. We are interested in cos inverse of x. So what we'll do, we'll take the image of this graph on the line y equal to x. So let me draw y equal to x first. Again, we'll notice that the domain of the function is minus 1 to 1, and range of the function is from 0 to pi. Okay. If we'll take the image, how will it look like? This part will map to this. Image of this part will be this. Okay, and image of this part on that line will look like something this. This will be the image of this part. Okay. Now domain is from minus 1 to 1, so this point out here will be minus 1. Here it will be 1, and range is from 0 to pi. Let me extend a bit. So this point here will be pi. So this will be the graph of y equal to cos inverse of x. Again, this one is cos x. The black one is cos x, and the green one is going to give you cos x. Sorry, cos inverse of x. Okay.